You know, when you look up at the night sky and you get away from all the city lights, you see this just impossible number of stars. Billions right here in our own galaxy, and then billions of other galaxies out there. The numbers are so huge, it just feels inevitable that we can't be alone. And yet, all we hear is silence. So today we're diving into one of the most profound and honestly, unsettling questions in all of science, the Fermi Paradox. The whole thing really started with this simple, almost casual question from the physicist Enrico Fermi way back in 1950. He was just looking at the sheer odds and wondered, why haven't we found any evidence of aliens? It's such a simple question, right? But it cuts right to the heart of this massive cosmic mystery. And this is the core of it. On one hand, you have the math, which pretty much screams that the universe should be absolutely teeming with civilizations. But on the other hand, our observations show, well, nothing. Just an empty, silent cosmos. This is the Fermi Paradox, and it's a puzzle with some truly fascinating and, sometimes downright terrifying potential answers. To really get why this paradox is so paradoxical, you have to wrap your head around the scale we're talking about. Our galaxy has had billions of years for civilizations to pop up, evolve, and spread out. And even if they were traveling at slow, sublight speeds, a single civilization could colonize the entire Milky Way in just a few million years, which, cosmically speaking, is the blink of an eye. So yeah, the silence we're hearing, it's absolutely deafening. Let's explore why that might be. Okay, so the first category of solutions is maybe the simplest one, and maybe the loneliest. It basically says there is no paradox, because the starting assumption that life is common is just plain wrong. What if we are, for all intents and purposes, completely alone? This leads to a fascinating idea called the rare Earth hypothesis. The thinking here is that Earth isn't just some regular old planet, it's a cosmic jackpot winner. For complex life to get going, you need this perfect storm of conditions. The right kind of star, being the right distance from it, having a big moon to keep things stable, plate tectonics. The list just goes on and on. So maybe the universe is full of simple microbial life, but intelligent, tool-using life like us? Exceptionally, unbelievably rare. And that brings us to this really powerful concept called the Great Filter. Think of the evolution of life as a giant obstacle course. The Great Filter is a hurdle that's so high, so difficult, that almost nobody makes it over. It could be one single thing or a whole series of challenges. But the big question is, where is this filter? Just look at the path life has to take. It has to clear every single one of these hurdles to become a star-faring civilization. So here's the crucial question. Where is the Great Filter? Is it behind us? Maybe the jump from a single cell to a multi-cell organism is just incredibly rare, and we're one of the lucky few who made it. Or is the filter still ahead of us? Now that's a much more sobering thought. It could mean that advanced civilizations almost always destroy themselves before they can colonize the stars. All right. Let's shift gears and move to a totally different set of possibilities. What if the galaxy is full of advanced civilizations, but they're all deliberately staying quiet? This solution suggests the silence isn't an absence of life, but a very conscious, very deliberate choice. Two of the most compelling and very different theories for this are the chilling dark forest hypothesis and the estivation hypothesis. The dark forest idea is straight out of a sci-fi thriller. The universe is like a pitch-black forest full of silent hunters. You can never know another civilization's true intentions, so the only winning move is to stay hidden and, destroy any other life you find before it finds you. The estivation hypothesis is a little less terrifying. It proposes that super-advanced civilizations are basically just hibernating, waiting for the universe to cool down so they can compute more efficiently. They're not dead, they're just waiting. And of course, there are other ideas too. The zoo hypothesis paints us as some kind of protected species in a cosmic nature reserve being intentionally left alone. Or, hey, maybe civilizations are only loud with radio signals for a tiny blip in their history before they move on to communication methods we can't even imagine. It'd be like us trying to find ancient smoke signals in an age of fiber optics. Now, if the first two solutions weren't strange enough for you, our third category really goes off the deep end. It challenges the very nature of reality itself. What if the empty universe we think we see isn't the real universe at all? This is the planetarium hypothesis. The idea is that we are living inside a perfect simulation, and whoever created it has simply programmed the sky to look empty. They've built a kind of planetarium for us, maybe to study us or maybe even to protect us. It is a completely wild idea, but it's one that some very serious people have considered.
And this is where philosopher Nick Bostrom's argument comes in, and man, it is a powerful one. He basically says that one of these three statements has to be true. So, if you believe that civilizations like ours will someday be able to run super realistic ancestor simulations, and that they'd want to run lots of them, then the statistical odds are absolutely overwhelming that we are in one of those simulations right now, instead of the original base reality.
So, with all these mind-bending possibilities floating around, what are we actually doing about it? Well, we're not just sitting around theorizing, we are actively searching for an answer. We are listening.
The biggest player in this field, by far, is the Breakthrough Listen project. It is the most comprehensive, most powerful scientific search for alien technosignatures, any sign of technology, that humanity has ever attempted. We're talking thousands of hours on the world's most powerful telescopes.
And this is no small-time operation. It's backed by $100 million. That kind of money represents a huge investment in this question. It's allowing scientists to scan 1 million nearby stars and the 100 closest galaxies, covering way more sky and way more of the radio spectrum than ever before, all in the hope of finally breaking that great cosmic silence.
What's really exciting, though, is how technology is speeding up the search. There's a new AI system that can sift through all this telescope data 600 times faster than the old methods. But it's not just about speed, and this is the really cool part. This AI can spot complex, totally unexpected signal patterns that a human researcher might just scroll right past. It's looking for the unknown unknowns, which could be the absolute key to making first contact.
And so, that leaves us right here, with this final question. We've gone through the chilling, the lonely, and the downright bizarre possibilities for why the universe is so quiet. But as we keep listening, we're left to wonder, what would truly be more profound? Learning that we are utterly and completely alone in this vast cosmos, or for that deep, endless silence to one day finally be broken?